Hello and welcome to the first ever episode of Let's Look At with Spirit of Cat. My name is Spirit of Cat and today we're looking at TIS-100. This is a new game from Zachtronics, the creators of Spacechem, Ironclad Tactics and Infinifactory, some of my favourite puzzle or strategy games on the PC in the last few years. Now this game, TIS-100, is a programming based puzzle game. It revolves around a fictional computer with a number of processors, which are interconnected and can pass data between them, and you have to solve various programming challenges or puzzles by writing assembler-like code to control those little processors or CPUs. Now, I've played through and solved the first 5 puzzles. Some of them I've come up with multiple solutions for various types of efficiency. It's hard to describe this game without just showing how it's played. It comes with a PDF manual, which they suggest you print out and have by you when you're trying to learn how to play it. I've read through the manual and I have some previous experience with programming in assembler, so it's all fairly easy for me to understand. So I won't be bothering with the manual, but there is, I can't bring it up now, I have to go into a level first. So let's create new program for sequence generator. Okay, in here, if I press F1, it shows me a quick reference. So these are all the commands that I can use in its little assembler-like programming languages. NOP, which is no operation, does nothing, just uses up a cycle, can be used to make one thing wait while another thing happens. Move, MOV, this moves something from a source location to a destination location. Sources can be the sides of one of these boxes, and they can also be the accumulator labelled ACC for each processor. Swap swaps the values in the accumulator and the accumulator backup. Save copies the accumulator into the backup. Add adds the number at the source specified to the value in the accumulator. Sub, same thing but subtracts. Neg negates the value in the accumulator. So if it's say positive 5, it becomes negative 5, and again if it's negative, say negative 10, it becomes positive 10. And then we have the various jump commands. Jump, which is an unconditional jump, jumps to a particular part of the program no matter what. Jump equal to 0, jump not 0, jump greater than 0, and jump less than 0. As you might expect, they will all jump conditionally depending on the value in ACC and how it relates to 0. And then JRO, jump to a relative offset. This allows you to jump back or forward an arbitrary number of lines within your code. It can also be fed the value of the accumulator or the value of any of the sides, the ports on the sides of the processors. So that's very flexible but kind of scary. Probably not much use in the early game anyway. So that's the command set we have. The layout here, we have at the top inputs labelled in A and in B in this case. We have the various boxes which we can type code into. That's where we put our code, and each box will execute the code on its own and it will talk to the other boxes through the ports on the sides. And then down the bottom we have the output. There can be multiple outputs labelled in dot whatever, like the out dot whatever, like the inputs were. In this case we have only one output. We also have some boxes which are not available, labelled in red. They have input ports but no output ports, so they can't pass anything along. These are generally just there to get in your way, and the ones that have a debug button have a little part of the story inside them. So we won't worry about the story for now, because I want to try to avoid spoilers as much as possible, being that it's a puzzle game and there are limited solutions, and working out how to solve things is part of the fun. So I'm going to demonstrate, I haven't looked at this puzzle yet, so I'm going to demonstrate my process in trying to solve this puzzle, and that will be the demonstration of this game for my let's look at of it. So, sequence generator. Sequences are zero terminated. Read values from in A and in B, write the lesser value to out, write the greater value to out, write 0 to end the sequence. Okay, so in A and in B will both give us numbers. We're going to have to write to out. We're going to have to write first the lesser value, then the greater value, and then 0. So we're going to have to compare those two numbers somehow and work out which one needs to be output first. So the way this will work, first thing we're going to do is we're going to want to move the value, which is coming in at the top, so that's the port known as up. We'll move that into the accumulator so we can work with it. And the same for this one, move up into the accumulator. Now, how do we compare? The way to compare if one thing is greater than another thing is what? And what happens when they're equal? I guess they're never, well, it doesn't matter if they're equal, does it? Because they'll both be the same and they'll come out. Doesn't matter which one you output first. So, to tell the difference between two numbers, if I subtract one from the other, so say I subtract B from A. So if we move the value in the accumulator to the left port here, now we can take it from the right port, subtract the value on the right port from the accumulator. What this will do is it will be A minus B. So in this case, first case, it will be 46 minus 71. Since B is larger than A, the result will be negative. And we can test whether it's negative or not with one of those jump values, jump statements. But in doing this process of moving it over and subtracting it, we will have lost the value of A from originally. We just have the difference between the two now. So before we do the subtraction, we're going to make a copy of it. There are two ways we can do this. We can either back it up or we can shift it into another processor and then shift it back when we need it. I used that shifting in another program I had and it seemed quite effective, but it's probably a bit of a waste. Backup seems to be the more sensible option. So first we're going to save. So we're going to move the value of A into the accumulator, then we're going to use save, which will copy it from the accumulator into the backup as well. Then we can do the subtraction. Then once we've done the subtraction, we can test. So the test is jump if greater than 0. So if the value left in the accumulator is greater than 0, that means that A was the larger. So I'll make a comment in here, comments with a hash comment. This is if A is the greater. If A is greater. So if it is greater than 0, which means it was the greater of the two numbers, then we'll jump to label greater. Alright, and then we'll create a label called greater, which is what will happen. But before that, we need to do what to do if it isn't greater. So that's the jump, and then we have if A is less. We could write this better. Instead of writing if A is greater, we can write if A is greater than B. If A is not greater than B, my washing machine just kicked on in another room. The door is closed, and I don't know if that sound is going to get through, but I guess we'll just have to look at the VOD afterwards and see, and then plan not to do streams while the washing machine is running if it is audible. But for now, we'll persevere. Okay, so if A is not greater than B, then we're going to have to do something else. So we still haven't worked out what we're going to do with these values. Alright, so if A is a, write the lesser value to out, then write the greater value to out. So if it's the lesser value, it needs to go first. So we need to swap, that'll bring the backup value back into the accumulator, which restores the A value we wanted. And then we want to move the value of the accumulator to wherever it's going, down to the next the next processor, I guess. Move it down to there. So these values will have to be non-zero, since the values should be zero terminated, I hope. I'm going to use 0 as a signal for this one, so we can receive from there, move the value from up into the accumulator, and then we can jump if equal to 0 to a label called wait. Now, what's going to happen now? So we're passing the value down. If A was greater, we're going to pass move 0 down, and then swap, and then move the accumulator down. Okay, that's inefficient coding. Let's make that less than 0 instead, because then we can just go move the 0 down in here, and since the rest was the same, we'll change this to lesser to make it make sense. We'll change that to less, and that to not less. Okay, so if it's less, we move 0 down, which is a signal to the next one to tell it to wait and pass the other one in after B has been passed first. So what we're going to want to do, I should have done it all on this side because there's more room. This communication failure is going to be a problem. Or maybe I should just pass them this way and then bring them around. Never mind. Let's see how we go with this. Okay, so what are we going to do? If it's a 0, that's going to mean we have to wait, which is going to be a number of again, we don't want to put the wait out there. Everything's backwards in this language. Jump if not 0 to go, and go being send it out immediately, which will be move back to the right so it can be sent out. Otherwise, it's going to be a matter of taking this one. So this value over here, we're going to have to also move down. And then in here, we're going to move up into the arc. So we have a hold of it. And then, what's going to happen? We're going to move the arc to the left. Oh, this starts to get complicated, doesn't it? We can use that one for extra storage. Yeah, let's do that. Since we don't have to do any comparisons, move up, left. And then this one can do move right, arc, move arc, right. So I can use it there to store it, and it will just sit there waiting until it's needed. This one takes that, passes it over there, and that's the true value which we're going to actually be passing back there. Meanwhile, B is coming in here, and we're going to move the value from the right into the arc, and then move god, we can't even, we've got to use the arc first here to jump, then move arc left. So that stores it over there while we use it here to make this decision. And we're going to have to either move right into the arc again, okay, so we're going to spit it out one way or the other, because we've got the two values waiting for us, one on left and one on arc. So this is going to be move arc right, and then move left, right, and this one is going to be move arc right. So they're both doing the same thing, but in a different order. So this, after moving left, is going to expect two values coming back. So it's going to move left down and move left down. Take both of them and spit them down. This one's going to move up, down, and move 0 down. And that, fingers crossed, is going to get the job done. So, what happens, for those who couldn't follow what I was doing, is values come in through both of these inputs. I save both of them in the accumulators. I send this one over to here. I compare the two to see which one is the lesser. Oh, there was a problem, wasn't there? Because if it was non-zero, we go. But if it wasn't non-zero, then we're going to be putting, yeah, we got a problem there. Okay, so we put that value, which is either 0 or the A value, into the accumulator, and we check it. If it's non-zero, we're fine, except it means we've got to first move the accumulator to the left. If it is 0, we've got to get the real value from up there again, move up to the accumulator, except we don't even need it in the accumulator because we're fetching it from the left every time, aren't we? So we're just going to move up left directly. Okay. that should be right, except we don't want to do both of these, so we're going to have a jump to the top, and then we define a label up here called top, so that we can skip doing the go section otherwise. Yep, okay, that should work. So we're passing down either 0 or a value. If it's a 0, then that means we have to wait, so we'll grab the next value, which was the a value, because it comes down second if that's the case. We're going to put it over here, and it's going to be ready to come back when we need it. Meanwhile, we're going to take the b value, which has been passed across, in, and then we're going to spit it straight back out, followed by the a value, and then go back to the top ready for the next one. So that'll spit them out in the right order. If it was not 0, if it was the a value straight away, then we move it over here first, we pull this one in, store it, then we push that one back out, and then we put that one back out, giving us the right value. So unless I've got my polarity backwards, which is possible, which would mean I'll get every value wrong except for the zeros, this should work. So let's just run it and see. Looking good, looking good. Yep, that seems to be going. 136 cycles, 147 cycles, 140 cycles, random test. Alright, 147. Slightly heavy on the cycles compared to the majority. Oh, way up in instruction count. I must have overcomplicated this. There must be a way simpler way to do this. Look, I've got 30 instructions. People are getting only just over 12 instructions, probably 14 or something. I used 6 nodes. Some people are using 5 or 4, I guess. My cycle count is okay, but not brilliant. So it could use some refining. See, that's the beauty of this game. Just like with games like Spacechem as well. You can find a solution. Finding a solution is usually not too hard. The real trick is optimizing your solution so that it runs quickly and neatly. So obviously my way was not the best way, but it's a way. And I'm going to spend time making it better, but that's probably enough for the video. You'll be able to tell, I think, from this whether this is the kind of thing that you'd like to play or not. So I'll sign off now. That is the end of this first look, or this let's look at of TIS-100. Thank you for watching.